Dear friends, today we will try to understand the Paleogene succession of India. Different kinds of the rocks which are found of the Paleogene age in different parts of India are being discussed here. So, let us first talk about the Paleogene in general. Physiographic features of India took final shape during Cenozoic era. The Paleogene period began with the outburst of the lava flow mainly over southern parts of Indian craton called as Deccan volcanism, a marine transgression on the western, northern and eastern flanks and with tectonic instability in the Tethyan Himalayan arc. Let us come to the Paleocene. At the end of Maastrichtian, a major regression occurred which produced an unconformity that extends at many places into lower Eocene, but in Assam, South India and Tibet, which was short-lived and soon followed by a transgression in the early Paleocene or Danyan, making the first tertiary transgression in the Indian subcontinent. It was followed by a regression before the main late Paleocene Raniko transgression began. During the late Paleocene, the sea transgressed in the northwestern part of the subcontinent into Himalayas, Tibet, Assam, Burma and also in South India. At the same time, an arm of the sea from Sindh covered areas in Rajasthan, Kutch, Cambay regions up to Surat, Bharuch in western Indian coast. Overall, paleobotanical evidence suggests tropical to subtropical conditions in the subcontinent. An analysis of the marine fauna shows close affinities between the species of northwestern region and those of the Tibet and northeastern region. Indian fauna closely resembles the former from the Mediterranean Tethyan zone and from the Indo-Pacific region. The important foraminiferal species which allow recognition of the late Paleocene marine succession are Ranicotalia sinensis, Miscellanea miscella, Alveolina or Glom alveolina primea, Discocyclina ranicotensis or Lochartia hemi. The paleontological evidences suggest that during Paleocene, the sea existed north of Indian Shield from Afghanistan to Burma, and in the context of the plate tectonics, it is suggested that the Indian Shield was still separated from the Asian platform. The sea allowed considerable migration of the fauna between the Tethyan zone and the Indo-Pacific region. The late Paleocene was also a time of the tremendous volcanic activity in western and central India. Another center was Burmese Andaman Nicobar Arc, situated approximately on the extension of the 90 East Ridge. Now, let us come to the early Eocene, which is equivalent to Laki in India. Towards the end of the Ranikot time or Paleocene, another regression took place in most part of the region. In Sindh Baluchistan, coal deposits formed during this time along with the Assam and West Bengal. In Burma also, this phase is represented by a conglomerate. The end of the late Paleocene therefore marks a break in the marine sedimentation in major parts of the Indian subcontinent. At the commencement of the early Eocene, however, a widespread marine transgression occurred covering a fairly wide area. The evidence of this transgression is seen in the form of a widespread distribution of shallow neritic facies represented by nummulitis, Sindh, Baluchistan, Salt Range, Himalayas, Tibet, Assam, Burma, Kutch, Rajasthan and also parts of the southern India. The palynological data suggests a tropical to subtropical conditions. However, there is a definite decrease in the biotic diversity. It is interesting to note that the families of plants reported from Assam region are different from those of the western sector, and it is possible to differentiate the two kinds of flora during the early Eocene times. Marked decrease shown by the floral diversities is also reflected by all marine groups present in the deposits of this type. The decrease is most well marked in the diversity of mega invertebrates such as corals and mollusks. A sudden decline in the biotic diversity can be attributed to the number of causes, of which the most significant is the beginning of cooling trend. Climatic changes have been deduced on a relative basis on the hypothesis that organic diversity decreased from equator to polewards, meaning that it is inversely proportional to the temperature. Other factors influencing marine diversity are reduction in salinity from the increased freshwater influx and increased supply of detrital material from the Himalayan orogenic impulses. The early Eocene deposits are recognized on the basis of following typical species of larger foraminifera like Acelina granulosa, Acelina davisi, Nummulitis irregularis, Alveolina oblonga, Discocyclina species, etc. A reasonable good development of nummulitic fauna is the distinctive feature of the early Eocene deposits in the subcontinents, marked by the first appearance of nummulitis. Early Eocene was also a time coal and lignite formation, as is evidenced by the occurrence of coal belt along the western coast from the central and western Gujarat in northwestern to Palana in Rajasthan and further westwards in Pakistan. Evidences is also known from a number of localities in Jammu and Kashmir. In Assam, the early Eocene coal belts is well developed in the southern part of Shillong Plateau and in the Mikir Hills. It is seen that the coal belt is proximal to the shoreline, almost parallel to the coastline of Sindh Barmer seas. No terrestrial mammals have been reported from the Laki sediments, but their diversity and abundance have been noted in the mid-Eocene. The land connection with the adjacent countries of Asia had not been formed. In Paleocene, the Sindhu and Barmer seas had extended across the northern part of the subcontinent, connecting western and eastern flanks. In the Eocene, they were cut off by the emergence of the island arcs and other regions of the high relief in areas of southern Tibet and eastern Nepal. This became the nucleus of the further orogenic activity. Thus, Sindhu Sea extended into the Tibet, but its connection into Assam at the end of the early Eocene is doubtful. There was also a sharp decline in the intensity of volcanism in the peninsula. It was mostly confined to the parts of the central India. Now, let us come to the mid to late Eocene, which is equivalent to Kirtha. During the mid Eocene, the Tethyan Ocean transgressed across the northwestern part of the Kutch, Cambay region, Rajasthan, Sindh, Baluchistan and Potwar. In the Himalaya, it was mainly confined to some areas of the lesser Himalayas. Very few of the plant families present in the Paleocene and early Eocene epoch are represented. In the mid to late Eocene, however, those that are present indicate that the climate remained tropical to subtropical, though some temperate elements confined to northeastern parts are also present. The occurrence of families or dicot family Dipterocarpaceae in the deposits of this epoch in the western, northern and southern and eastern parts of the India is distinguishing feature also. Coal deposits diminished in thickness and extent and geographic distribution. Coal is found in Tura or Garo Hills, Meghalaya, near Bharuch in Gujarat, southern Himachal Pradesh. In northern and western sectors, their occurrence are mainly on the basis of the oil well data. Marine Kirtha deposits are present in Sindh, Baluchistan and western and eastern parts. However, still have some common elements among foraminifera. Following forms help in recognizing the mid to late Eocene deposits like Nummulitis obtusus, Nummulitis beaumonti, Alveolina elliptica, Acelina exponens or Discocyclina dispensa, Dictyoconidis cookie. An interesting aspect of the Kirtha, that is mid Eocene marine elements of the eastern part, is the fauna that includes more Indo-Pacific province forms than Tethyan ones. The marine Kirthas are also include parts of the upper Eocene in several areas. For example, Surat, Bharuch and in Assam, it is characterized by the Nummulitis fabiani. The Pelatis species that is known from Assam is intermediate to the Tethyan facies of Pakistan and that of the Southeast Asia. In northern and eastern sectors, the Kirtha deposits show paucity of fossils. Reef-building corals also became rare in mid and upper Eocene in extra-peninsular region, except for the minor outcrops of the northwestern Pakistan. There is a transition from the predominantly marine sedimentation to fluvial condition during the end of Laki. The presence of the vertebrate in mid and upper Eocene beds of the northern India indicates that with the withdrawal of Neolithic Sindhu Sea, the fluvial conditions prevailed and supported a thriving fauna of the artiodactyls, crocodiles, turtles, and fishes. The change from the marine to terrestrial sedimentation was brought about in the mid-Eocene and has persisted till recent times. This suggested that there was an upheaval in Himalayas during the post-Laki or pre-Kirtha times, constituting an important landmark in the history of Himalayan orogeny. The vertebrates are significant in defining the time of impact of Indian plate against Asian plate and determining the time when the migration of the terrestrial vertebrates from the Central Asia occurred. During late Cretaceous and Paleocene, India was a highland subcontinent separated from Africa and Madagascar by a northwest ridge from Australia, by 90 east ridge from North Asian landmass, and by Tethys. No mammals are known from India until the mid-Eocene. Migration of large terrestrial and mammals such as the tapirids, artiodactyls, hyracocondyls, and the rhinoceratids south of the suture zone could only have taken place with the establishment of the stable conditions for dispersal across a land ridge. This indicates that the part of the drifting Indian plate must have collided with the Asian plate during the mid-Eocene. Now, coming to the Oligocene or Nari times, the widespread regression in the northern arc of the Indian subcontinent and the orogenic impulses at the close of the Kirtha times resulted in the significant change of the depositional history of Oligocene sequence. Though there is no essential difference of the Nari flora from the older ones, there is a decrease in diversity and abundance of certain families such as the Polypodiaceae or ferns are widespread in distribution. Some temperate elements are found in burial sediments of Assam. Extensive coal deposits develop in the Oligocene during regressive phase of the sea. However, the sites of the coal development have shifted eastwards towards Assam, Bengal, and Burma. In the western sector, there was a shallowing of the sea, whereas in the eastern sector, at places northeast and central Burma, there are extensive fluvial deltaic deposits. There is a marked difference in the taxonomic character of the Nari fauna. Of the marine fauna, the foraminifera of western sector show affinity to West Asian forms with over one-third of the species common, while mollusks are closely allied to European forms. The marine successions developed in the western sector are recognized on the basis of the following foraminifera, like Nummulitis intermedius, Nummulitis fischel, Lepidocyclina eulepidina, and Lepidocyclina nephrolepidina, and Heterostagina, Myogypsinoides complanata, Spiroclypeus ranjane. In the northern sector, a huge thickness of the sediments extends from Kashmir to eastern Himachal Pradesh and conformably overlies the Eocene Nummulitis or Nummulitids. These beds are non-marine plant-bearing, having Oligocene age consisting of sandstones and shales. They indicate that the Sindhu and Bengal seas had receded from the northern and the northeastern part of the subcontinent. Except some areas in northwestern, no younger marine rocks are reported from this region, and fluvial sedimentation has persisted into recent times. Great thickness of deltaic deposits in the northern Assam suggests that an extensive delta was forming by rivers carrying sediments from the rising Himalayas in the north. Swampy conditions existed up to Gondwana near Kolkata. The sea retreated southwards to a position of approximately 25 degrees 20 minutes north in the Oligocene. Later, the delta gradually progressed southwards with the addition of the more sediments during Neogene. Now, coming to the geological events During a Paleogene, having an interval of something around 65 to 24 million years, the world moved from greenhouse state to characterized by generally warm equator conditions to an icehouse state characterized by polar regions of the world that resulted in the considerable drop of the temperature. Now, let us discuss evolution of marine and terrestrial life. Marine group of animals, plants and single-celled organisms that survived the terminal Cretaceous mass extinction expanded during this period. Many benthic foraminifera, namely Nummulitis, Discocyclina, Alveolina, etc., or sea urchins, bryozoa, crabs, gastropoda, bivalves, and teleost fishes appeared during the Paleogene and assumed prominent ecological conditions. The most significant feature is the re-emergence of the reef-forming corals, which have been reduced to very subordinate position in the reef-forming activity. As a result of the dominance of rudisted bivalves during the late Cretaceous, the reality of early Paleogene coral reefs also indicates that the recovery of corals from mass extinction was not quick and is associated with the establishment of the right tropical conditions to initiate carbonate deposition during the Eocene that supports corals and other related biota. Diatoms and dinoflagellates were not affected from the mass extinction and continued their survival. The only survivor amongst the planktonic foraminifera, that is Globigerina, radiated again and evolved complex morphotypes. Irregular echinoids and sand dollars evolved from in the discrete shapes from the race of Togosiamus. Other comers from the ocean margins were penguins, whales and sharks. Some Paleocene mammals have been assigned to primates. The upper Eocene in particular was marked by more modern varieties of the hoofed herbivores known as ungulates, for example, living horses, camels, sheep, goats, pigs and rhinos. The earliest elephants appeared during the Paleocene or during the Oligocene. The modernization of the mammals continued and many living groups expanded. An important aspect of the mammalian evolution was the appearance of modern monkeys and apes like primates. Thank you very much.